one of the really important things that you have to be able to do with all differentiation, but it becomes even more important with differentiation of trig functions, is to be able to use the chain rule. Okay, so we've got our new rules for the differentiation of sine, cos and tan. We need to be able to apply those using chain product or quotient rule as appropriate, and this video focuses on the chain rule. So one of the first things we're going to look at is just two really straightforward chain rule questions, and then this question here is a chain rule within a chain rule, and we'll look at ways of tackling these. So with your first question that's here, okay, if you want to follow it using the actual chain rule as in your formula booklet, all right, what we would want to do is define it as y equals g of u. And then we want to go with u equals f of x. Okay, so we've got f, which is our internal function, and g, which is our external or outer function. Okay, so when you're working with this, g of u is the outer function, f of x is going to be our inner function. You've got to be careful with use of variables, but there's nothing really conflicting here, except that in this question, it's not x, it's t. So we need to go a little bit further with what those functions are. G of u, the outer function here is a cos function, so it's cos of u. The inner function here is t squared. Okay, if you're really having trouble seeing inner and outer functions, all right, we've got a t squared there, and that is part of a cosine function. All right, so t squared is our inner function, cos of t squared, cos of u, is our outer function. All right, so we've set up everything that we need there. To find the derivative of this then, if we look back at our quotient rule, chain rule, sorry, dy dx equals dy du times du dx. Okay, what does that mean? Well, that means we multiply the derivative of the outer function by the derivative of the inner function. Okay, so if we go back to our two functions, start with our outer function first. Our outer function, the derivative of cos, is negative sine. Okay, so dy du, the derivative of y with respect to u, is negative sine of u. We're then going to multiply by, let me just do some color coding, the derivative of our inner function. Okay, so differentiating our inner function, which is t squared, is very straightforward. 2t. And then we just replace u with what it actually was. So tidying all of that up, it's negative 2t sine of u, which is t squared. Okay, so that's setting it out in full. But we can just work with this idea here of multiplying the derivative of the inner function by the outer function. Now, if you're having difficulties identifying those, then I probably do recommend the full solution. However, the other way of going about this is to go, okay, I'm going to find the derivative. I need to multiply the derivative of the outer function. So the derivative of cos is negative sine of something, and that something is t squared. And we multiply that by the derivative of the inner something, which was t squared, and that is 2t. And so we've done it, a couple of minutes versus 30 seconds. All right, and so, it would be great if you could get to the point of being able to work through it that way, following that process. Okay, multiply by, find the derivative of the outer function multiplied by the derivative of the inner function. Okay, but if you need to, you've got the full working process there. Okay, so that's the first one. The second one, y equals 1 over tan of x, that's also very much just a straightforward chain rule function. So let's do our definitions again. Y equals g of u, and u is going to be f of x this time. We're good with x. G of u, the outer function, well, if we're having trouble seeing that, I've got tan of x, which is part of a 1 over function. So that's my outer function, 1 over u. And my inner function is tan of x. Alright, so dy dx equals dy du times du dx, outer derivative multiplied by the inner derivative, the derivative of the outer function, 1 over u. Alright, we would want to write that as u to the negative 1 before we differentiate. We multiply by the power and subtract 1 from the power, times the derivative of the inner function, which is 1 over cos squared x. Sorry, I messed up my highlighting here. Outer function, inner function. And then we just have to work our way through and tidy that up. Negative u, now what was u? U was tan of x, times 1 over cos squared x. That is negative 1 over tan of x squared, times 1 over cos squared x. I'm going to have to scroll down through here. So we've got to that point. Alright, so here is one perfectly appropriate and valid solution. However, you do need to be able to simplify these things, because if you get to this point and then have to solve some kind of trig equation, it's going to be much easier if you've simplified it. So, keeping in mind that tan of x squared, I'm not differentiating, I'm just rewriting it, is that, and we're multiplying it by cos squared x, hopefully you can see that what we have is a cancellation of cos squared x, and that leaves us with negative 1 over sine squared x. Only a little bit more here in that I want you to be able to simplify these trig expressions to make it easier if you then have to go on and do any further work. Alright, so these two are two very straightforward chain rule questions. Now, on to the last one. So, with this one, there's a chain rule within a chain rule, okay? And I know we use this notation where we put the cubed above the sign, but it's actually much easier to work with differentiation if you do that, okay? And now you should be able to see that we have, I'll use a different color, an inner function and an outer function. So let's just work with that for the moment, okay? G of u is equal to, and it's okay, I'm not using g of u or anywhere. I'm just going to redefine that as y, just to make it easier. G of u is going to be u cubed. That's our outer function. Our inner function in this case is, and it was f of x, but we're already using f of x, so we really shouldn't use it again. Let's use h of t. And that's going to be what we defined u as. The actual letters you use here, h of t, it really doesn't matter. What I'm trying to do here is just not double up on the pronumerals that I'm using. And that's equal to sine of 2x. And then we have a problem here where we have this function, which is actually a chain rule again. It's a pretty straightforward one, but it is still a chain rule. And we have an inner function and an outer function. And so we would need to do another set of chain rule working off to the side here. All right, let's have a look at how using that shortcut process makes this a lot easier. So, what are we looking at here? dy dx. Okay. Y, x, yeah? So that's going to be dy du. Sorry, that can be h of x, it just shouldn't be f. Mess that up. Multiplied by du dx. Alright, all good. So, dy du, nice and easy. That's 3u squared. Alright, that's my outer function. My inner function, sticking with the same color coding system, is sine of 2x. Now I know that that's a chain rule. So let's work it over here. U equals h of x, which equals sine of 2x. Sorry, sine of w. I can't use u again. I can't use h. Let's go that w, is j of x. I'm just using different letters here. And that's 2x. So, du dx equals du dw times dw dx. Derivative of sine of w is cos of w. Derivative of 2x is 2. Okay, now we could do that using a shortcut, and I'll do that in a second. So, that's the derivative of the inner function. Alright, that is what I'm going to sub in here. Times 2 cos 2x. Okay, tidying that up gives me 6u squared cos 2x. Then we sub back in for u. That's what u is. Put that back in. That's 6 sine 2x cos 2x. Alright, how can I do that the shortcut? Right, so f of x is sine cubed of 2x. Okay, so derivative of a cubic is going to be 3 times that inner function squared, sorry I missed the squared there, multiplied by the derivative of the inner function. The derivative of this is 2 cos 2x. Which works out to be the same. So mastering that shortcut is really powerful. Okay, chain rule with trig functions, incredibly important. Okay, can you use that chain rule to differentiate any of those trig functions?